Hey, Math 186 kids, we are so close to being done. Next to last lecture. Hang in there. 10.3 is all about the hyperbola. Lots going on in this guy, so be patient. Make sure you have your notes next to you and you understand the details. If not, make sure you zoom in. We talked about last time this equation of an ellipse in standard form. The hyperbola is very similar. We still have x minus h squared over a squared, and we still have y minus k squared over b squared equals 1. If it was an ellipse, we would have a plus here, and the a and b would give us measurements inside of our ellipse. For a hyperbola, we have subtraction. You remember the difference between the equation of a hyperbola, or all the points on a hyperbola, versus an ellipse is that if you pick any point on the ellipse and we have our focus and our line, that the difference remains constant. So this is a horizontal hyperbola. Sorry, I sort of squished that in there. All right, we identify the center, although it's not part of it, it helps us draw it, is HK. The transverse axis is going to be y equals k. That's going to be, well, you'll see it when I put it in the picture on the next page. The conjugate axis is going to be the equation y equals x. So the transverse axis in a horizontal hyperbola is just y equals the y coordinate of the center. The conjugate axis is x equals the x coordinate of the center. And absolute value of a, what's under here, is the distance from the center to the vertices. Okay, a horizontal hyperbola is going to be shaped like this. All right, so now let's put all this into a picture in general. So bear with me, there's lots of information in here. So how can we draw a hyperbola? Okay, this is not my x and y axis. This is going to be my transverse axis and my conjugate axis, which we'll see in an xy plane in a moment. So first thing we do is in the xy plane is we plot the center. Again, it's not part of the graph, it's just identification to help us draw this guy. So the center all depends on the the value inside the parentheses with the x, the value inside the parentheses with the y. So this is my center and it's at HK. So the center is at HK. This is going to be my transverse axis in a horizontal parabola. So this is going to be my transverse axis, the larger one axis, and it's going to be at y equals k. So it's just going to be the line through the center, the horizontal line through the center. My conjugate axis is the axis that does not actually pass through the hyperbola. That's going to be x equals h. Right, then we're going to have the two vertices. The distance from the center to the vertex, well, we find the value of a by taking the square root of that denominator. So this distance is going to be a. This distance is going to be a. Right? And then we draw a box with vertical lines from a. Let me see if I can find a color without making this too dark. So we go a units to the left of the center. This is not part of the graph, but it is direction to help us find the graph. So we draw a box a units to the right of the center, where the left and right sides are a units from the center, and then the bottom of the top and the bottom of the box are whatever that is. This distance is going to be b units from the center. Make that darker. So this is b up. And this is going to be b units down, and we draw the top and the bottom of the box b units above and below the center. Now how that's going to help us is if we go diagonally across the box from corner to corner, these lines are going to provide us asymptotes to actually help us draw our hyperbola. So now yet we haven't even drawn the hyperbola yet. All we have so far are the two vertices. These two are part of the hyperbola that mark the left and right side of the box on this horizontal hyperbola. All right, so we draw these lines. These are just asymptotes. Right? And the slope of this one is, well, it's, if we start here and go to this point, we go up B and over A, so it's B over A, and the slope of this asymptote is just negative B over A. So far we've only have 2 points of our hyperbola right here. The focus is what we talked about when we defined that, the defined hyperbolas previously, and the distance from the center to each focus. So this is, let me find an appropriate pen. I'm just going to call this the focus. It's not part of it, but it is part of the defining feature of a hyperbola. So this is another focus. This is the vertex. That's vertex 1. This is vertex 2. And then this distance is C, where C squared is A squared plus B squared. We've seen this before with our ellipse. Right, so now you can plot some points, but usually typically what we do is we just do this, and it goes up, and it's going to follow that. It's going to look like this. Like this. There we go. That's what it's going to look like. Huh. Now that is a horizontal hyperbola. Let's graph one before we go to the vertical parabolas. So before we mumbo jumbo our brain with more of this. So let's suppose this was my example. I'm going to keep going back and forth between these two. So we are going to graph x minus 4 squared over 16 minus y minus 3, y plus 3 squared over 25. Now, how do you know if this is horizontal or if it's vertical? Well, you'll see the difference in the vertical afterwards, but if the term, the term of the hyperbola that's positive is x, it's going to be a horizontal hyperbola. Where here the y term is negative. These two are going to switch and it's going to make it a vertical. All right, so let's define some features. Here, this tells me that A is 4, and this tells me that B is 5. Those are going to be important features. Let's do C squared is going to be 16 plus 25. So C squared is 41. C is positive negative square root of 41. We'll need that in a little bit. So the center of this hyperbola is 4, negative 3. Remember, it's always opposite of what's inside. The transverse axis is going to be the y equals negative 3, right? So the transverse axis is always the horizontal line that goes through the center when we have a horizontal parabola. The conjugate axis is the vertical line that goes through the center. So that's going to be x equals 4. So I'm going to plot the point. I'm going to go 1, 2, 3, 4. Down here's my center. That's the point 4, negative 3. Now it's not part of the graph, so I will change the color when I do the graph. That's the center. Right, so now I'm going to draw my little box. My box is going to go 4 units to the right and the left of the center. So if I measure out 4 units to the right, I'll be right here. I measure 4 units to the left and I'll be right here. So now those 2 points are really important. 4 units to the left of the center, and we get that from A. And 4 units to the right of the center will be right here on the y-axis. So here's my 2 vertices. This is going to be 8, negative 3, and that's one vertex. My other vertex will be 0, negative 3. Right. So I'm going to draw the lines that go through the vertex. Oops, let my pen dry out. All right, so here's the vertical line through x equals 8. Here's the vertical line, which is the y-axis. So that's going to be the 2 sides of the box. Now I'm going to go up 5 units and down 5 units from the center. So if I'm down here at negative 3 and I go up 5, I'm going to be here at y equals 2. That's going to be the top of my box. And I'm at negative 3 and I go down 5. I'm going to be at 1, 2, 3, 4, 5. I'm going to be at negative 8. So let's put that up there. So the bottom of my box is at -8. And now I'm going to draw my asymptotes in. I'm going to go corner to corner in my box. And that's going to be the asymptotes that are going to help me draw my hyperbola. Right there. Right. So it's really just going to go like this. It's going to skim along there. And it's going to skim out like that. It's going to go that way. And it's going to go that way. So it might ask you for the foci. So the foci, remember, are the points here that help us define our ellipse. Right? So this distance from here to here is going to be the square root of 41. So the coordinates of this point is going to be 4 plus the square root of 41. And then my height would be at -3, and that's one focus. And then this point would be 4 minus the square root of 21, also at -3, height of -3, and that's the other focus. Now, it's not part of the actual graph, but it is if we look at this line and any point on the graph and we measure the distance from the focus to the point to that vertical line, the difference in the distance would remain consistent by definition of a hyperbola. Here we go. Anything else? I think that's it for that guy, right? All right, so how does a vertical hyperbola, try that again, how does a vertical hyperbola different than a horizontal one? Well, here's the equation of our horizontal parabola. Here's the equation of our vertical hyperbola. Backpedal, I'm so sorry. End of the semester, I'm really whooped. Try again. Here's the equation of our horizontal hyperbola. Here's the equation of our vertical hyperbola. Notice that the y term is the positive term, the x term is the negative term. So whatever term is positive, that's the direction in which it opens. So here, x is positive, so it opened this way, pointing in the right and left. Here, the y term is positive, so this guy's going to open up and down. All right, so now we just have to do a little bit rearranging of the terms. So I know this is really super confusing. It's just a lot of details to remember, and I'm not going to make you memorize all these, I promise, okay? So let's go to, this is, we have, oh, right here, I got to write it down. We got to go back to the general equation. I didn't do that guy. So equation, all right, so a vertical hyperbola in standard form. Right, we're going to have y, it's still y minus k all over b squared, and we're still going to put the b with that just to avoid any more confusion. All over a squared is 1. Okay, so now let's look at all the details of this guy. So the center, it's still in the xy axis. So the center is still at the point HK. So H comes first and K comes second. This time, the transverse axis, the one that's actually going to pass through the hyperbola, is the horizontal line, x equals b. Nope, sorry, x equals h. I knew that. X equals h, the x coordinate of the center, where the conjugate axis will be the y equals k. So they're just going to switch roles. It's like the major and the minor axis. And then this time, the absolute value of b is the distance from the center to the vertex. Right, so this time our vertices are going to be on the top of the box instead of the sides of the box. So let's see if we can put that all into perspective. So here we have a vertical hyperbola in standard form. So my center is still at the point HK. Remember, this is not my x and y axis. This is going to be the transverse axis. And it's going to be x equals h. And this is going to be my conjugate axis, y equals k. And then we're going to have vertices here and here. So that's my first vertex. And the distance from here to my vertex is going to be, it's going to be whatever the center is. Well, let me see, we're going to go up B. So we're going to go up B. So I'm just thinking, I might have not did that. So I didn't actually put the coordinates of the vertex in. Okay, so this distance is going to be B. So we're going to start at K. My X coordinate's going to be the same, but we're going to start at K and go up B units. Here, my X coordinate's still going to be H. We're going to start at K and go down B units. So that's one vertex. And I didn't put that detail in the other graph, sorry. Right, now the sides of the box are, well, this is still B. Right, we're going to go to the right, left, and to the right A, to the left A, and we're going to draw our little box. So it's the same box as we drew previously, A units to the right and the left of the center, and B units to the top and the bottom of the center. And then we're going to draw the diagonal lines from here to here. That. And then I'm going to go from my vertex here is going to go like this. It's going to be my graph. And this one's going to be down this way. And my focus is going to be, the distance from the center to the focus is going to be C. Right? And that's going to be C. This is one focus. This is the other focus. And C squared equals A squared plus B squared. All right. All right, kids, let's do an example.